All right, 4.8. Today, we will be discussing what are called transformations. So a transformation is an operation that moves or changes a geometric figure, so for example a triangle, in some way to produce a new figure. So there are many different kinds of transformations. We have reflections, which you should be familiar with, where you take something and flip it, right? We also have what are called translations, where you take an object and you slide it left, right, up, and down. We also have rotations, which we'll talk a little bit about today. And then finally dilations, which we'll get to at a later time. So, I should mention the new figure after the transformation we call the image. So, the first example is a translation. A translation moves every point of a figure the same distance in the same direction. So, our figure isn't changing shape at all, okay, but it is moving in some way, shape, or form. So, we always start with the blue picture, okay, that's going to be the original. So then the image is going to be the red. Well, if you take two corresponding points, so say this one, and then down here we have E prime. Whenever you see this prime, this apostrophe, that's part of the image. So if we look at E, we move down 6 and to the left 3. So in words we say translation is down 6, left 3. We can also write that in what's called coordinate notation. So this is telling us that all of our x's and y's, well, we're going to subtract 3 from every x, subtract 6 from every y. Okay? Because again, we're going 3 to the left, so that's negative, and 6 down, which is also negative. So this is coordinate notation, which you'll be using quite a bit in this section. So the next one we have is a reflection. It's where we have a flip, and for this class, for this section, we'll be flipping over either our y-axis or x-axis. So again, the blue one's the first one, the red's the image. So this we call a reflection across the y-axis. So again, one thing you want to notice here is that all the points are the same distance away from that line of reflection. Okay? So again, it's a mirror image reflection. And coordinate notation, well, if you look at all these points, well, C just stays the same because it's on the axis. But if you look at, say, A, for example, we're at -4 and 3. And then over here, we're at 4, 3. Even though we're reflecting across the y-axis, our y value is not changing, it's the x value. We're changing the sign. So coordinate notation here would be -x, y. Whereas if we were reflecting across the x-axis, it would be x, -y. So those are your reflections. And then finally we have rotations. So a rotation turns a figure about a fixed point called the center of rotation. Now for us, we're going to keep that fixed point the origin, the point 0, 0. So here we have a 90-degree counterclockwise rotation about the origin. So again, counterclockwise, we're going blue to red. You should all know what counterclockwise is, I hope. And here's the notation. XY goes to -y and x. So you'll notice that these two switch order, and the y is going to change when you go counterclockwise. So when points are rotated, they're going to stay the same distance away from that origin. So notice after the rotation, A is the same distance away on both of them. You could check with the distance formula on that. Difference between your x's is 3, so that'd be 3 squared. Difference between the y's is 1. That would be square root of 10. And you get the same thing here. Difference of your x's, well, that's 1, so 1 squared. Difference of your y is 0 to 3, so 3 squared. Square root of 10. That would be the same for b and b prime and c and C prime. So that's your rotations, counterclockwise or clockwise. For us, we'll keep them at either 90 degrees or 180 degrees, something pretty easy to figure out. So some examples says draw the image after the translation. So here we're given our translation and coordinate notation. So this tells us that all our x's are going to go up by 3. So positives, we go right, so right 3. Y's, we're going to go down 4. So I take A and I'm going to go right 3 down 4. So there's my A prime. Okay, same thing with C, so right 3 down 4. C prime. B, right 3 down 4. And there's B prime. So here's my image right there. Down 4 and right 3. Next, it says, what's the coordinate notation of a translation left 2 and 3 up? So when you're writing coordinate notation, okay, follow this example, you need x and y. And an arrow. Well, we're going left 2. Well, to go to the left, that's a minus, so x minus 2. And up 3, so y plus 3 is that coordinate notation. It says graph the coordinates and determine if the transformation from segment AB to segment CD is a rotation. Well, let's first graph it. So A, let's go blue to red here. So A is at 1, 1. B is at 4, 2. So here's AB. And then we have CD. So C is at 2, negative 4. And then D is at 1, negative 1. Oops, I graphed that last one off. 2, negative 4 is down here. And then 1, negative 1. So there's D, and here's C. So we're trying to determine if that's a rotation or not. Well, let's check to see that we're the same distance from the origin. So if we look at A and D, well, they're both up 1 over 1, so that's the same. And then B and C to the origin, those also look the same. So if you did distance formula, well, for point B, subtract your x's, 4 minus 0. Y's has a difference of 1. That's square root of 17. And then down here, we have difference in your x's of 1 and y's is 4. And we get the same answer. So because the points remain the same distance away, we can say that this segment is rotated. This would be clockwise, 90 degrees. However, one thing you might notice is that A now corresponds with D and B now corresponds with C. So that makes it a little iffy, but the segments themselves are rotated, okay? Because this order doesn't really matter here. It's not a congruent statement like you use for triangles. So this is a rotation clockwise 90 degrees. 4 says complete the statement using the description of the translation. Okay, it says if negative 1, 2 translates to negative 2, 6, then 3, 3 translates to blank. Well, let's figure out our coordinate notation is the easiest way here. Well, what happens to your x's? Negative 1 to negative 2. Went down 1. What happens to your y's? 2 to 6, up 4. So now let's do the same thing here. Subtract 1, we'd have 2. Add 4, and we'd have 7. Number 5, a point on an image. So again, the image is after the translation, and the translation are given. Find the corresponding point on the original. So we got to 4, 3. This is the point on the image, the new one, by doing this. So we're working backwards. So to work backwards, we do the opposite of add 3. Subtract 3. 4 minus 3 is 1. Do the opposite of subtract 2, so add 2. And we get 5. Okay, so a big thing in this chapter is understanding this coordinate notation here. Okay, it's a large chunk of understanding this assignment. Here's your assignment. Speaking of, you will need graph paper. So make sure you get some graph paper with you if you don't get this done before you leave for break. Other than that, and if you're not going to be here tomorrow, have a happy Thanksgiving. Don't choke on your turkey. Unless your name is Craig.